Welcome to RenewEnergy.com, your renewable energy and sustainability platform. At RenewEnergy.com, we believe in the power of clean, sustainable energy to transform the way we live and work. That's why we offer a range of solutions for businesses and homeowners looking to switch to renewable energy sources such as solar, wind, and water. Welcome to RenewEnergy.com. In today's video, we'll focus on an element that plays an astonishing role in our universe: hydrogen. What makes hydrogen unique? For starters, it is the most abundant element in the universe and holds the prime position as the first element on the periodic table. Why does hydrogen matter? From powering stars to serving as a key component in clean energy solutions, the applications of hydrogen are vast and incredibly diverse. The objective of this video is to provide you with a comprehensive understanding of hydrogen. We will explore its history, delve into its unique properties, and examine its modern-day applications. So, stay tuned as we embark on an exciting journey to uncover the captivating story of hydrogen, an element that not only powers the stars but could very well fuel our future. Elemental basics, defining hydrogen and its position in the periodic table. Hydrogen stands as the first element in the periodic table, signifying its unique position in the realm of elements. With the atomic number 1, it serves as the cornerstone upon which the entire periodic table is built. In its elemental form, hydrogen is a gas that consists of diatomic molecules, denoted as H2. Each hydrogen atom has one proton and one electron, making it the simplest of all elements in terms of its atomic structure. While hydrogen is commonly found as a molecule, it is highly reactive, and in various conditions can form compounds with other elements, like oxygen to form water or carbon to form hydrocarbons. These compounds showcase the versatility of hydrogen in chemical reactions. Due to its simplicity and reactivity, hydrogen also serves as a standard for atomic mass units and is often used as a reference in various scientific measurements. This elemental simplicity, coupled with its abundance and reactivity, makes hydrogen not just the starting point of the periodic table, but also a cornerstone in the fields of chemistry, physics, and beyond. Early understandings, pre-discovery theories and alchemical concepts. Before hydrogen was recognized as a distinct element, various theories and alchemical concepts tried to explain the substances that make up our world. Alchemists, who can be considered the spiritual predecessors of modern chemists, were deeply involved in the study of substances and their transformations. One of the primary concepts was the idea of the four elements: earth, water, air, and fire. These were thought to be the essential building blocks of all matter. Hydrogen, as a gaseous substance that could easily combust and also form water, would have puzzled alchemists due to its multifaceted nature. Additionally, the concept of phlogiston was prominent during the 17th and 18th centuries. This hypothesized substance was believed to be released during combustion. Interestingly, hydrogen, being flammable, would later challenge and ultimately help debunk the phlogiston theory. Alchemy's focus on transformation, turning base metals into gold, for example, also indirectly contributed to our understanding of elements like hydrogen. The experiments conducted by alchemists laid the groundwork for scientific methods and provided valuable insights into the behavior of different substances, including gases that we now recognize as hydrogen. It wasn't until the 18th century, with the advent of more systematic scientific methods, that hydrogen was isolated and identified as a unique element, thereby revolutionizing our understanding of chemistry and setting the stage for modern science. The Cavendish experiment: profile, laboratory setup, and observations. Henry Cavendish, an English scientist, was the first to isolate and identify hydrogen as a unique element in 1766. Cavendish was an incredibly private man but highly respected in scientific circles for his rigorous methods and detailed observations. In terms of laboratory setup, Cavendish used fairly rudimentary equipment by today's standards, but it was state-of-the-art for its time. He combined metals with acids to produce what he initially called inflammable air, noticing that the gas was lighter than air and that it produced water upon combustion. Cavendish's observations were meticulous. Upon collecting the gas, he experimented by sparking it in a closed container. He observed a violent reaction that produced water droplets on the inner walls of the container. This experiment was instrumental in identifying hydrogen as a distinct element and recognizing that water is a compound consisting of hydrogen and oxygen. His works were documented carefully, and the scientific community soon realized the importance of his findings. Cavendish's experiments not only identified a new element but also laid the groundwork for future studies on chemical composition and reactions. This monumental discovery set the stage for the subsequent naming of hydrogen and its inclusion in the periodic table. Cavendish's work also opened the door to a deeper understanding of chemical elements and compounds, forming the basis for modern chemistry. The naming of hydrogen, Antoine Lavoisier's role in etymology. While Henry Cavendish is credited with the discovery of hydrogen, it was Antoine Lavoisier, the French chemist, who gave the element its name. Lavoisier is often referred to as the father of modern chemistry, and his contributions extended to reforming chemical nomenclature, among other things. The name hydrogen is derived from Greek words, hydro, meaning water, and genes, meaning creator or origin. The name was fitting given that one of hydrogen's most notable properties is its ability to form water when it combusts in the presence of oxygen. Lavoisier's naming was not arbitrary but was part of his larger effort to systematize chemical nomenclature. Before this, names of elements and compounds were often descriptive but inconsistent. Lavoisier aimed to bring order to the lexicon of chemistry, and his naming of hydrogen was a part of this endeavor. This official naming was a critical step for the scientific community, as it provided a standardized way to refer to this newly discovered element. It also emphasized the element's unique properties, reinforcing its role in the formation of water and setting the stage for future research into its diverse applications. By giving it a name that encapsulated its properties, Lavoisier not only immortalized hydrogen in the annals of science but also provided a cornerstone for the developing field of chemistry. Hydrogen in the cosmos, its presence in stars and role in cosmic evolution. Hydrogen is not just a significant element on Earth, it plays a fundamental role in the cosmos. It constitutes about 75% of the observable universe's elemental mass, making it the most abundant element by far. One of the most critical roles hydrogen plays is in the life cycle of stars. Stars, including our Sun, are primarily composed of hydrogen. Through a process called nuclear fusion, hydrogen atoms combine to form helium, releasing enormous amounts of energy in the form of light and heat. This energy is what makes stars shine and is also the source of energy for life on Earth. Furthermore, hydrogen is a key player in the cosmic evolutionary process. Its presence in interstellar clouds acts as a catalyst for the birth of new stars, perpetuating the cycle of cosmic evolution. In terms of astrochemistry, hydrogen is also found in various celestial bodies like gas giants, and it plays a role in phenomena like nebulae, which are essentially vast clouds of gas and dust. These nebulae are often the birthplaces of stars, and hydrogen's reactivity makes it a significant component in the molecular complexity that can lead to planetary systems and, potentially, life. By understanding hydrogen's role in the cosmos, scientists can gain insights into the fundamental processes that govern the universe. Hydrogen on Earth, natural occurrence and early applications. Although hydrogen is abundant in the cosmos, its presence on Earth is mostly in combined forms rather than as free hydrogen gas. Water, for instance, is a compound of hydrogen and oxygen, and hydrocarbons like methane consist of hydrogen combined with carbon. Natural occurrences of free hydrogen gas on Earth are rare and are usually the result of specific chemical reactions or microbial activity. For example, some microorganisms produce hydrogen during the process of fermentation. Hydrogen is also released in small amounts from volcanic activity and can be found in some mineral deposits. In terms of early applications, hydrogen has been used in various forms for centuries. It was initially explored as inflammable air, given its tendency to combust. In the 19th century, hydrogen found applications in airships and balloons due to its low density, though this practice was eventually largely abandoned in favor of safer gases like helium. Furthermore, hydrogen has been used as a reducing agent in metallurgical processes. Its high reactivity allows it to strip away oxygen from metal ores, making it valuable in the extraction of metals like iron. Today, the applications of hydrogen have evolved substantially, from its role in chemical industries to its emerging promise in clean energy technologies. Its early applications paved the way for understanding its properties better, thereby broadening the scope of its utility. Modern uses in vehicles, hydrogen fuel cells, advantages, and challenges. Welcome to a fascinating segment where we explore the state-of-the-art application of hydrogen in fuel cell vehicles. Imagine a world where your car runs on a fuel that emits nothing but water and heat. Sounds like a dream, right? Well, hydrogen fuel cells are turning that dream into a reality. Let's delve into some of the advantages. Fuel cells are incredibly efficient and produce zero emissions. They could revolutionize the way we think about transportation, reducing our dependence on fossil fuels. But it's not all rosy, there are challenges. The current cost of hydrogen production can be high, and let's not forget the logistical issues of storage and transportation, which still need innovative solutions. Modern uses in renewable energy, role in wind and solar energy storage. Hydrogen is carving a unique niche in the renewable energy sector, especially when it comes to wind and solar energy. Ever wondered what happens when these renewables produce more energy than we can use? The surplus can actually be used to produce hydrogen through a process called electrolysis. This is a game changer, as hydrogen serves as an energy buffer, balancing out the demand and supply of electricity. When we need the energy back, the hydrogen can be converted into electricity, helping to stabilize our increasingly renewable-based grids. Environmental impact: hydrogen as a clean fuel and sustainability concerns. As we transition toward more sustainable living, hydrogen stands out as a promising clean fuel option. It offers an environmentally friendly alternative to fossil fuels when produced from renewable sources. However, let's be clear, much of today's hydrogen production is based on natural gas, which isn't renewable. The question then is, can we make hydrogen truly sustainable? Fortunately, strides are being made in water electrolysis techniques, and ongoing research aims to mitigate the environmental footprint of hydrogen production. Summary, future outlook, and upcoming innovations. As we come to the close of this enlightening journey, we'd like to thank you for joining us here on the ReneeEnergy.com YouTube channel. Today, we've navigated through the compelling story of hydrogen, from its fundamental properties and historic milestones to its transformative roles in modern technology. Looking forward, the horizon is bright with promise. With ongoing advancements in hydrogen fuel cells, energy storage solutions, and sustainable production techniques, hydrogen continues to spearhead scientific innovation. So, what can we expect in the years to come? Well, from breakthroughs in electrolysis methods to new materials that facilitate better hydrogen storage, the future for this versatile element is full of possibilities. As we wrap up, we leave you with this thought-provoking question: as we strive for a more sustainable future, could hydrogen be the missing link that helps us transition away from our dependence on fossil fuels? For more in-depth discussions on topics like these, be sure to subscribe to our channel and visit ReneeEnergy.com for additional resources and insights. Thank you for choosing ReneeEnergy.com as your go-to source for all things renewable energy and sustainability. With our YouTube channel, we explore the latest developments and innovations in the field, including hydrogen fuel cells and the use of AI and machine learning to optimize energy consumption. If you're ready to take the next step towards a cleaner, more sustainable future, visit us at ReneeEnergy.com and discover the many ways we can help you transition to renewable energy. Thank you for watching and subscribing. Stay up to date on all the latest news and insights by subscribing today.